Alright, so in this problem, I have 2 to the power of x is equal to 5 to the power of x plus 7. So, I actually have 2 methods to solve this problem. So make sure to stick around for the video to see me solve both methods. So for my first method, method 1, I'm going to write my problem right here. 2 to the power of x is equal to 5 to the power of x plus 7. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 5 to the power of x plus 7, I can write that as 5 to the power of x times 5 to the power of 7. And now, from here, I'm going to divide both sides by 5 to the power of x. So then these two cancel out, and I get 2 to the power of x over 5 to the power of x is equal to 5 to the power of 7. Now from here, an important property of exponents is that if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 5 to the power of x is equal to 2 over 5. And another property is that if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 2 over 5 to the power of x. And this is equal to 5 to the power of 7. Now from here, I'm going to take the log on both sides. So I get log 2 over 5 to the power of x is equal to log 5 to the power of 7. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. In this case, I have log 2 over 5 to the power of x, so I can move x to the front, and I have log 5 to the power of 7, so I can move 7 to the front. So I get x times log 2 over 5 is equal to 7 times log 5. Now from here, we obviously want to find the value of x, so to do that, we have to get rid of log 2 over 5 by dividing both sides by log 2 over 5. So then these two cancel out, and I get x is equal to 7 times log 5 over log 2 over 5. And we have our answer here. This is our solution, but there is a way to simplify it more. So first off, if I have something in the form log a over b, this is equal to log a minus log b. So log 2 over 5, that's going to equal log 2 minus log 5. And now from here, I get 7 times log 5 over log 2 minus log 7 times log 5 over log 5. And these two cancel out, so I get 7 times log 5 over log 2 minus 7. And this is the same thing as 7 of log base 2 of 5 minus 7. Now for method 2, what I can do is, my equation was 2 to the power of x is equal to 5 to the power of x plus 7. And now I'm going to just start by taking the log on both sides. So I get log 2 to the power of x is equal to log 5 to the power of x plus 7. And now using that property, I get x times log 2 is equal to x plus 7 times log 5. And now if I distribute the log 5, I get x times log 2 is equal to x times log 5 plus 7 times log 5. Now if I subtract x times log 5 on both sides, these two cancel out and I get x times log 2 minus x times log 5 is equal to 7 times log 5. Now I can factor out x, so I get x times log 2 minus log 5 is equal to 7 times log 5. And divide log 2 minus log 5 on both sides. So these two cancel out and I get x is equal to 7 times log 5 over log 2 minus log 5, which again simplifies to this. So x equals 7 times log base 2 of 5 minus 7 is my answer. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now, to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front, and I have log 5 to the power of 2, so I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143, so I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.